covalent compounds are those compounds where the electrons are being shared. So you have covalent bonds, and covalent bonds they share electrons. So whenever you have two atoms connected by a covalent bond, the electrons are going to be shared between those two atoms. So we have a modification for the rule of naming when you have ionic versus when you have covalent compounds. So if you have a list of compounds and you have to write down the name for those, you need to make sure that you know if they are ionic or if they are covalent. And the easy way for you to identify something as ionic or covalent is to check the formula of your compound to see if you have a metal. Okay? So if you have a metal in your compound, the metal will always be on the left side of your formula, or it will be the element that appears first in your formula. So if you have a metal, that compound will be classified as ionic. If you don't have a metal on the left side of your formula, then you're going to have a covalent compound. You can also have an ionic compound if instead of having a metal, you have your polyatomic ion NH4 plus 1, which is ammonium. So if you have a metal or ammonium, you will have an ionic compound. But if you don't have a metal or ammonium, then you will have a covalent compound. So the rule for naming for everything that we did for ionic compounds is that you're naming the first one, which is your metal for ionic compounds, as it is in the periodic table. And then the name for the second element that appears in your formula, you're naming that one, which is the negative part in your ionic compound, using IDE. So for covalent compounds, we have the same thing, but with a minor modification. I'm not writing here name of the metal as it is in the periodic table because you don't have metals for covalent. So I'm writing down name the element that you have on your left side of your formula, or the first one that appears in your formula as it is in the periodic table, and you're going to write down after that the name for the element that you have on the right side of your formula using the ending IDE. This is the modification for your rule. We're adding a prefix in the naming for covalent compounds because when you have ionic compounds, you can determine how many ions you're combining in your formula based on the charges. So your total charge for an ionic compound is 0. The total number of positive charges has to be the same as the total number of negative charges. If they are the same, they will cancel out. When you have covalent compounds, you don't have ions in your covalent compounds. Electrons are not being transferred, so you don't have positive and negative charges here. So you cannot determine how many atoms of each one you have in your formula based on charges, like what you can do with ionic compounds. Since we cannot use the charges to determine how many atoms or how many we have for each element in your compound, we add a prefix. That prefix is going to tell you how many you have for the first one, how many you have for the second one. So we have here a list of the prefixes and what the amount that they represent. So mono all the way to deca, and that's 1 all the way to 10. So when you're naming your covalent compounds, the name for the first one, the name for the second one, and you're going to use your prefix to indicate how many you have. So if you're naming this one here, that will be monocarbon dioxide. This is a compound that probably you know. Carbon dioxide, you have heard that name a lot of times. We don't name or we don't mention the name including the mono. We say carbon dioxide. So that's because whenever the prefix for the first element in your formula is mono, and only for mono, you can actually omit that one. If you have mono for the second one, you have to write it down. if the first prefix is different from mono, you have to write down that one too. The only one that you can omit from the name, it's mono, and it's only for the first element in your formula. So the name for this one here, 1 and 1, since the first one is 1, I don't have to put mono for that one. I can write down just carbon. The name for the second one, using the ending IDE, is not oxygen, it will be oxide. But you have 1, so for that one you have to put carbon monoxide. I'm adding the mono because the mono belongs to the second one in your formula, so you have to write that one down. I'm not adding mono for the first one because it's the first one, and that one you can omit. So let's see what we have here. I like this example because you have silicon, and silicon is not classified as a non-metal. It's not classified as a metal. Silicon, it's a metalloid. So for metalloids, we also apply the same rules that we're using for covalent compounds. We're not using the one that we have for ionic. So for that compound right there, the first one, you have only one silicon. So for that one, you don't have to write down the mono. So I'm just writing down the name of the element as it is in the periodic table. Then you have 2 oxygens, and for oxygen we don't use oxygen, we use oxide, and you have 2 of them. So that will be silicon dioxide. And I'm going to do the second one, and then you can work the other ones. Nitrogen is the first one that you have. It's just 1. You don't have to write down mono because it's for the first one. You have 3, and for Cl in the periodic table you have chlorine, but you don't use chlorine, you use the ending IDE, so that will be nitrogen trichloride. And then I have here 3 examples where I'm giving you the name for you to write down the formula. Since this is only for covalent compounds, you don't have a mixture, you have only covalent compounds. But if you have a list of compounds, the first thing that you have to do is to check that you have ionic or covalent. For the ones that you're writing a prefix, it's only for your covalent compounds. You don't have to use a prefix for ionics. So I'm going to do the first one, di and chlorine. That will be Cl, and you have 2 of them. Mono is just 1, and then you have oxide. So you can do the other 2.